Hi, it's me, Dr. Prasad Puthiyillam, on my YouTube channel, My Intuition, offering regular as well as entrance coaching classes for chemistry and learning mathematics. This is class number 5 of Basic Concepts of Chemistry, Mole Concept and Molar Masses with Avogadro constant, percentage composition, empirical formula, and molecular formula. Mole concept. We use the idea of mole concept to count the entities like atoms, molecules, particles, electrons, ions, etc. at microscopic level. For example, it contains the elementary entities, it may be atom, molecule, or particle, or electron, or ions. These elementary particles are contained 6.022 multiplied by 10 to the power 23, or the number given 60221367 and 16 zeros. Okay, that contains in 1 mole. That much elementary entities are present in if you take exactly 1 mole of that compound or that particular compound. This number is called Avogadro constant, represented by Na, and its unit is mole inverse or per mole. So 1 mole of a substance always contains the same number of entities, no matter what the substance may be. Say example, if you consider 1 mole of hydrogen atom contains Avogadro number of atoms, or 1 mole of water molecules contains Avogadro number of molecules. 1 mole of sodium chloride contains Avogadro number of formula units of sodium chloride. Therefore, 1 mole of a substance always contains the same number of entities. So the mole concept and molar mass. The molar mass of 1 mole of a substance in grams is called its molar mass. The mass of 1 mole of a substance in grams is called its molar mass. So molar mass of water is 18.02 gram per mole. It means 1 mole of water, that is 6.022 multiplied by 10 to the 23 Avogadro number of molecules, has a mass of 18.02 gram. That 1 mole contains 18.02 grams. Molar mass of sodium chloride is 58.5 gram per mole. It means 1 mole of sodium chloride weighs 58.5 grams. If you can take 1 mole of sodium chloride, the weight will be 58.5 gram. That means 58.5 gram of sodium chloride contains 1 mole of sodium ions as well as 1 mole of chloride ions also. Therefore, we can say 58.5 gram of sodium chloride, if you take, it consists of 2 moles of ions, 1 mole of Na plus and 1 mole of Cl minus. Therefore, total 2 moles of ions are present in 58.5 gram of sodium chloride. That point to be noted. Percentage composition. It is a percentage of elements, not an element. It's a percentage of elements present in a compound. For example, water consists of hydrogen and oxygen elements. Then we can say mass percentage of element is equal to mass of that particular element in the compound divided by the molar mass of the compound multiplied by 100. It will get the percentage of mass of that particular element. So example, mass of percentage of hydrogen in water, H2O, that will be 2 multiplied by mass of hydrogen, that is 1.08, divided by molar mass of water, that is 18.02, multiplied by 100 to get 11.18. So 11.18 percentage of hydrogen is present in water. Mass percentage of oxygen in water will be 16, that is the mass of atomic mass of the element mass of oxygen, divided by total mass, that is 18.02, multiplied by 100. 88.79 percentage is the mass of hydrogen, percentage mass of hydrogen. Empirical formula and molecular formula. An empirical formula represents the simplest whole number ratio of various atoms present in a compound. If mass percentage of various elements are present in a compound is known, if you know the value, then empirical formula can be determined easily. Whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. If you know the molar mass is known, then molecular formula can be calculated or it can be determined. Therefore, we can say if the mass percentage is given, we can find out the empirical formula. We can derive empirical formula. From empirical formula, we can calculate the empirical formula mass. And if molar mass is there, then using those empirical formula mass and molar mass, we can find out even molecular formula also. So an example is given. A compound contains 4.07% of hydrogen, 24.27% carbon, and 71.65 percentage chlorine, its molar mass is also given as 98.96 gram. So we need to find out the empirical formula as well as molecular formula. So different steps will follow. First, we will convert the molar mass percentage to grams. So it is given percentage 4.07, 24.27, 71.61 percentage, and no other element is present. Therefore, total percentage, that is a out of 100. Therefore, if you say that if 100 grams of the compound is there, then 4.07 grams of hydrogen is there, 24.27 grams of carbon is there, 71.65 grams of chlorine is there. So okay, you can say that much amount of elements are present. Convert into number moles of an each element. That we can do by multiplying by respective atomic masses. So we got 4.07 gram of hydrogen. It can be converted into its number moles by dividing with that. Okay, therefore we can calculate moles of hydrogen is 4.07 divided by 1.008, that becomes 4.04. Moles of carbon, 24.27 percentage was there, so that is 24.27 grams divided by 12.01, that is the atomic mass of carbon, becomes 2.021. Moles of chlorine, 71.65 percentage is given, therefore it becomes 71.65 gram divided by the atomic mass of chlorine, that is 35.453, becomes 2.021. So you can write that moles of hydrogen is 4.04, moles of carbon is 2.021, moles of chlorine is 2.021. So dividing each of these mole values which is obtained by the smallest whole number. Okay, so here the smallest number, that is carbon is 2.021, chlorine also 2.021, that is the smallest number. 4.04 is not the smallest one. So 2.021 will divide each of these one with, therefore it becomes approximately 2, 1 and 1. Therefore I can say give the ratio of 2 to 1 to 1 for hydrogen, carbon and chlorine. Therefore we can write it by, in case of say if the ratio is not number, then it is not the ratio. Say we got 2, 1, 1. If you are not getting ratio, if a rational is there, a fraction is there, then we need to convert into corresponding whole number by multiplying by suitable coefficient. Okay, so here we got exactly 2 to 1 to 1 for hydrogen, carbon and chlorine. Therefore the empirical formula can be written by giving the respective number. So 2 hydrogen, 1 carbon, 1 chlorine, therefore H2CCl, or we can say CH2Cl. CH2Cl is the empirical formula of the given compound. Now molecular formula. So we got empirical formula. From that we can find out molecular formula easily. We need to find the empirical formula mass, that is CH2Cl, carbon 12.01 plus 2 hydrogen, that is 2 into 1.008, plus chlorine at mass is 35.453. So we are getting 49.48 gram as the empirical formula mass. The molar mass is given 98.96. Therefore dividing it 98.96 with the empirical formula mass 49.48, we are getting a number n 2. We write as n, a number n, that we use to multiply the empirical formula to get the molecular formula. Therefore we got 2. Empirical formula is CH2Cl, that is multiplied by 2, we are getting C2H4Cl2 as the molecular formula. So that is the way to find out the empirical formula and molecular formula if the percentage is given and molar mass is also given. Thank you very much for watching my video. Please do subscribe my YouTube channel and support me. Once again, thank you very much and have a nice day.